everyone. In this video, let us discuss about the CNN architecture. So now we have a clear understanding about convolutional neural network and about we have also covered about activation functions and what is pooling, what is padding. So we have a complete understanding about it. So let us try to understand how we can implement it in the practical way. Right, so in this video, we are going to discuss about several CNN architecture. So for this, I'm going to take two case studies. We will be discussing about two case studies. So one is about handwritten digit classification. So we are very much aware of this YAMNIS data set, right? So it is basically a handwritten digit classification. Here the input is a single channel image and the outputs, we have totally 10 outputs corresponding to digits from 0 to 9. So why do we call it as 10 outputs? Because the output could be 0 or 1 or 2 or 3 up to 9. So totally there are 10 outputs. So what is the input over here? A single channel image is the input. So in this data set, there are 60,000 training images and 10,000 test images. So when we look at each image has a label. So this is a very popular data set that is being used with CNN. And the second one, what we are going to look into is about ImageNet classification case study, which is provided by Annual World Cup for CV. So in this case study, input is a colored image, and here the difference between the last and this is that it has a massive output because it has 1,000 output corresponding to 1,000 object classes. And here the training images is 1.2 million, and it has around 1 lakh text images. So when we compare the orders of magnitude, it is more than the handwritten digit classification. Its magnitude is more in the sense like the image size is more and also the number of images is more, because in handwritten digit classification we had only 10 outputs, but here we have around 1,000 outputs, and in handwritten digit classification we had 60,000 training images, but in ImageNet classification, we have 1.2 million training images. And in the last one, we had only 10,000 test images, but here we have around 1 lakh test images, right? So these are the most famous case studies in CNN architecture. So now let us look into the first one, 𝐿eNet 5. So it is a 10-way neural network classifier. So here there will be 10 output neurons. Each corresponds to label 0 to 9. So what is the input here? The input is the handwritten digits, and it is tolerant of various transitions like rotation and scale. And it is basically used by banks to recognize handwritten numbers on digitized checks. So totally it has 4 weight layers. Now let us look into CNNs on ImageNet. The first one is AlexNet 2012. Here it is the first CNN which is able to classify ImageNet images. So it has improved benchmark performance, which means the top 5 on image data set from 26% to 15%. So it is a 7 layers deep network. Let me give you an example. So there is an image of horse, right? So here the top 5 predictions are, say it is like dog, hat, cat, bus, and say train. So in this case, if you see into the top 5 priority, there is no right prediction for this horse. So what will happen here? Here there will be one error. So say if I have 100 images, the number of errors will be counted. Say for example, there are 5 errors out of this 100, then the error rate will be equal to 5%. Hope you are clear with this error rate. So totally there are 100 images, and out of that, if there are 5 errors, then the error rate is equal to 5%. So the next one is about ZFNet. So here the top 5 error rate is reduced from 15 percentage to 11.2 percentage. Because in AlexNet we have seen that the error rate is 15 percentage, and that is reduced to 11.2 percentage in ZFNet. Right, and here there is no major contribution, and this is also 7 layers deep. We have seen that AlexNet has 7 layers deep, and the CFNet is also 7 layers deep. The next one is about VGGNet. So this is 2014. We are not very happy with this because it is not the winner for the classification challenge, but it was a winner for the local challenge. So if you look into this VGGNet, it is simple and elegant. And previously in ZFNet, the error rate was 11.2 percentage, but in VGGNet, from 11.2 percentage, it is reduced to 7.2 percentage. So it did not win the competition, but actually GoogLeNet won the competition, and it is 16 layers deep. When we compare with the ZFNet, it was 7 layers deep network, but this VGGNet is 16 layers deep network. So the next one is about GoogLeNet. So it is 2014. And this is the 2014 ImageNet winner. Here the image rate is reduced to 6.7 percentage. So whatever error rate we are discussing is just about top 5 error rate. And it has used inception modules. And it is 22 layer deep, and it has used sidecost function. So why the sidecost functions are used to get better gradient flow. So the next one is about 2015 ResNet. So 2015 ImageNet winner is ResNet with error rate 3.57 percentage. So it was actually major breakthrough deep learning had. So first truly deep network with 152 weight layers. So if you compare with the remaining networks, what we have come across till now, it has more weight layers, that is actually 152. So the next one is about CU image. So here actually nothing interesting, but it is 2016 ImageNet winner. Here the error rate is reduced from 3.57 percentage to 2.99 percentage. So here the landscape becomes saturated, and it has used ensemble approach of various networks, but it is not interesting though. So the next one is SCNET, that is 2017. So it was working by momenta, and it had the highest score, right? And it is actually called as squeeze and excitation network, and it was the last ImageNet challenge. So from AlexNet to SCNet, the error rate reduced from 15 percentage to 2.25 percentage. So we have come across several networks like eNet, AlexNet, ZFNet, VGGNet, GoogLeNet, ResNet, CU Image, and SCNet. Right? Hope this is clear to you. Let us meet in the next session.